Alright, so this is our presentation on the magnesium ion, and the most common form is Mg2+. The atomic number is 12. It has 12 protons, 12 neutrons, and 10 electrons. And the 2 plus comes from the fact that it's a cation that's lost 2 electrons. The atomic mass is 24.305. The atomic radius is 160 pm. The natural form is a solid dissolved into water. And the Pauling scale is 1.31, and that relates to electronegativity. The ionization energy is the first electron takes 737.7 kilojoules a mole. The second electron takes 1450.7 kilojoules a mole. And the third electron takes 7732.7 kilojoules a mole. And the reason the third electron takes so much more energy than the second electron is because once it's lost the second electron, it's already in this perfect 8 valence electrons, and so it doesn't want to get rid of that third electron. Alright, so some requirements that the body needs it for is that it regulates enzymes, it helps create Mg-ATP, which is the most common form of ATP, it breaks down fat and glucose, and it regulates calcium in the bloodstream. It's most prevalent in bones, and it can regulate cholesterol. In DNA, it stabilizes DNA and chromatin structures. It's a major cofactor in nucleotide repair, and it controls cell cycle and apoptosis, and it's important in membrane stability. So some negative effects of having too little of the magnesium ion is that you can have problems with cell division, apoptosis, weak cell membranes, and producing ATP. And too much magnesium ion, it can result in diarrhea, nausea and vomiting, lethargy, muscle weakness, irregular heartbeat, low blood pressure, urine retention, respiratory distress, and cardiac arrest. So some sources of the magnesium ion can be found in cashews, spinach, quinoa, whole grains, almonds, black turtle beans, and many other leafy greens and nuts. And the largest source of the magnesium ion is actually in ocean water. And calcium hydroxide is added to create magnesium hydroxide precipitate. And then hydrochloric acid is added to that to produce magnesium chloride. And then magnesium chloride then goes through a process called electrolysis, which then turns it into the magnesium ion. Alright, so this is a video describing what electrolysis does.
Electrolysis is electrical current flow through a liquid which causes chemical changes. Yes, you did hear that correctly. Current flowing through a liquid. Now, not all liquids can conduct. The liquid can be a molten ionic compound or an aqueous solution. In either case, it must be able to carry current. Let's take a common example, table salt. If you heat sodium chloride to over 801 degrees Celsius, it will melt. The liquid will contain free-flowing positive sodium ions and negative chloride ions. This simply means that sodium and chloride ions are free to move within the liquid sodium chloride. Positive ions are called cations. Negative ions are called anions. Now consider putting 2 electrical conductors into the liquid. Copper would be good as it has a higher melting point. Nothing happens to the ions at this point, but if we connect the 2 bits of copper to an electrical cell or power supply, then things start to get interesting. We do need to sidestep for a moment to look at electrical current in a metal. From our lesson Behaviour of Metallic Structures, we know that electrons in a metal aren't bound to particular atoms. They form a sea of electrons that can move easily if a potential difference or a voltage is applied across it. This could be from an electrical cell or a battery. The electrons will begin to drift towards the positive terminal of the battery, and this is what happens when current flows. Current is the movement of charge, in this case electrons. Now, let's go back to our molten sodium chloride. We've added our copper wires, let's call them electrodes, and now we'll connect these to an electrical cell. The electrons will start to flow in the wires, and this will cause one electrode to become positively charged and the other negatively charged. This has an immediate knock-on effect in the molten sodium chloride, which you'll remember is a mixture of sodium cations and chloride anions. Anything positively charged in the liquid, in this case the sodium ions, is going to be attracted to the negative electrode. And anything negatively charged, in this case the chloride ions, is going to be attracted to the positive electrode. This is because opposite electrical charges attract. When the ions meet the electrodes, electron exchange happens, and this triggers a chemical reaction. Solids can form, gases can be given off, and new solutions can be left behind.
So in our case, the magnesium chloride would be the solution that electrolysis is used on. And so the magnesium ion would be separated from the chlorine ion.